Thank you all very much. Thanks for having me here. I was thinking I'm the guy standing between all of you and drinks or whatever comes next, but it turns out I'm not. It's Salil, so I'm really happy about that. So I actually wanted to title this initially, How I Became a Better Engineer by Getting Better Financial Acumen. Right? And I actually believe that, but we'll get to that. But before we do, a little bit about Velocity Global. I'm the CTO of a company called Velocity Global. We basically make it easy for you to hire, retain, pay, provide benefits, be tax compliant in 185 different countries. You're looking to hire someone in wherever, Australia, we'll hire them, pay them, make sure you're tax compliant, give them benefits, and so on. That's the business we are in. I want to talk a little bit about, when I look around the audience here, obviously really smart people. And I suspect most of you have started out as engineers. And at least my career trajectory has looked something like this. At some point I thought, I write great code. I still write code, by the way, but my team won't let me commit anything to production. Then I rose up the ranks. I thought, I'm becoming a good engineer, a good manager. I take care of people. It wasn't really not till I got a little bit experience in that role and went further up in my role, I really started thinking, my job is making our customers, our employees and the company successful. That's really what I'm trying to do. And so in order to do that, I kind of had this framework, and I've got a blog. I call it very pompously the CTO Toolbox. You can look it up. And, these are some of the articles I have in there. I'm not going to walk through all that, but I kind of think about customer focus. How do we reduce the gap between engineers and customers? That's a lot of time. I spend a lot of time thinking about and solving for that. I spend a lot of time thinking about speed to outcomes, which all of us care about, right? We have to move fast. We have to solve our customers' problems fast, and we have to do it in a very scalable way. And finally, I think about the how do I help assess and upgrade the technology vision. Now, for those of you who know me, know that I have a very pronounced point of view on how I like to run things. In fact, I would say this L0 to L5 discussion that was at the previous panel, like I don't even understand what a server is any longer, was my, because I'm all like, pretty much everything I do is serverless. I really want to make all those racking and stackings and servers and VM someone else's problem. I'm not interested in solving that problem. So once you have this kind of framework and you start thinking about, okay, how does financial management really apply? The two things that are worth looking at are gross margins and operating margins. Right now, there are a number of financial metrics that your CFO and your CEO and everyone else in the company will be interested in, but these are the two I kind of think about a lot. So gross margin is revenue minus COGS divided. Oh, well, that didn't format particularly well, at least not. Oh, too bad. So, gross margin is revenue minus the cost of goods sold, right? And revenue is all about it's about the top end. How do I make, my products faster, better, and serve our customers better? Whereas cost of goods sold also includes the hosting costs, and that's something, all of us need to keep in mind. In the operating margin, you got gross profit minus the operating expenses. And the operating expenses actually includes the R&D expenses. And obviously, for most of us, not for everyone, payroll is the single biggest, cost that we have to think about, right? So when you think about a financial framework, you got to think about, how do I increase my revenues? How do I reduce my cost of goods sold? And how do I reduce my operating expenses, right? These are some of the variables that, you have to think about and play with. So when you think about gross margins, one way of looking at it, and, I most certainly wouldn't say this is an exact way of thinking about it, but an approximate way of thinking about it is you think about the maximum possible revenue, maximum revenue potential, and subtract the losses in the system that you have, right? And I'll talk a little bit about these losses: FCI losses, latency losses, availability losses are losses in the system. And each time you have these losses, you're actually taking away from your maximum potential revenue that you could be having. And some of these things are well understood. Other things maybe not so well understood. So when you're thinking about the maximum revenue potential, there are things like, there was a discussion in the previous panel also, how do you get to production very, very fast? Well, the goal I set for the team is code to production has to be in 15 minutes. How do we make that happen? Right? You set that target and then you work backwards from there and see what are the kinds of things you need to do in order to make that happen. It results in this fishbone of these are all the things that need to happen in order to achieve this goal. You obviously want to do rapid testing with customers. Rachit was talking about, running thousands of experiments at a time, absolutely important. If you haven't thought through an experimentation framework, you absolutely need to do that. People have opinions. Everyone has opinions. The only thing that really matters is what the customer is actually doing with the product. So you've got to run experiments. And the last thing is around, how do you actually reduce or manage things to the right level, availability. For most SaaS companies, that's 3 nines and a 5. If you're in payments or something, maybe you're aspiring to higher standards than that. FCIs, I'll talk about FCIs because FCIs tends to be something, a lot of people know about, but some people maybe not. And performance. Those are the 3 things that are possible places of losses in your system that you must be thinking about. How do I optimize this? So let's talk about latency for a second. This is something I have thought about a lot. I've been written about a lot in my blog. But the impact of performance, I'm sure most of you are very, very familiar with this. The numbers are just absolutely startling. The most crazy numbers that I have seen, I haven't put on these slides, was there was an engineer named Greg Linden, who's a former engineer at Amazon. And he did an analysis of what happens when Amazon's website slows down by a certain number of milliseconds. And it turns out that every 100 millisecond slowdown or increase in latency resulted in 1% reduction of revenue for Amazon. So those numbers honestly make no sense to me. 100 milliseconds seems almost imperceptible, but that is the reality. We are actually incredibly, aware of at what speed, pages load. So performance is hugely important. Google had an experiment where instead of returning 10 results at a time, they returned 20 results. And if you return 20 results, well, the page takes slightly longer to load. They lost one third of people actually just walked away. So the impact of performance is absolutely nuts. So the goals I set for the team, and again, depending on the industry you're on, whatever your context is, your goals might be different. It's important to set goals. For me, the goal is 50th percentile page load time has to be under 1 second. And 90th percentile has to be under 3 seconds. That's a going in position. And then we continue to actually keep improving from there. So the second thing is availability and failed customer interactions. Now, availability, I don't think I need to explain to anyone here. Everyone understands it really well. So I'm going to spend a little bit of time talking about failed customer interactions. So here's the thing. I think availability is an incomplete way of looking at the behavior of systems in the world that we live in. And here's what I mean by that. So for example, I've got 50 microservices running in the system that are providing certain services, and there's a problem with a particular microservice. Well, a certain piece of your functionality is not working. Well, does that count as an availability incident? I'm not really sure. I actually don't think so. However, a certain set of customers who have come here to your website who expect to be able to do something there were not able to do that, right? So there is customer unhappiness as a result of the fact that there is a partial kind of outage. Now, this could be because a particular microservice is down. It could be because there is a certain bug on your website. It doesn't really matter. The reality is there is a failed customer interaction, right? And those failed customer interactions, if you let it linger in your system, actually causes customer dissatisfaction in a way that, if you're tracking only availability metrics, you won't even see it. So it's really important to track failed customer interactions. And, for me, this is actually a priority. We attack it in engineering. In our company, we track it as a top-level metric. So the standard is less than 0.025% of interaction can be a failed customer interactions. And At my previous startup, a company called Inflection, it got acquired last year. So we started out at 3.2%. That was what we were actually seeing. And you can see the NPS score was a 63. And we actually kept working on it. And part of the solution for us was actually bringing Sedai in. And actually, with the help of Sedai, and by the way, everything at both my previous startup as well as my current startup just runs on Lambdas. We don't have much else. So we were able to get our FCIs down to pretty close to 0% or imperceptible. And that was actually a trigger for our customers actually giving us great feedback, for our engineering teams to be able to move really fast, because you're not worrying about these kinds of failures in the systems, and so it becomes a little bit of a virtuous cycle. You're moving faster and faster when you're taking care of things like failed customer interactions as a priority. Cool. Another part of the CTO's job is really, what technology should I invest in, right? And the reason this is important is, again, when you're thinking about the cost of goods sold, right? There are all the software expenses you need to be thinking about. You need to think about, how does it align with business goals? How does it offer competitive advantages and so on? I'm not going to go through this list, but all of us actually go through this. And the thing to keep in mind is, when on the expense side, the R&D expenses, when you look at your operating margin and therefore your operating expenses, the R&D expenses, you got to think really hard and deep about, because that is something that can actually, in competitive environments, that becomes a key value for you. Because if you're able to manage your expenses better than other companies can, you can not only deliver value better to your customers, you can probably figure out how to monetize this in ways that your competitors might actually have trouble competing with you. So the way I run these, this is via two mechanisms. So the first thing is, and there was, again, at the previous panel, there was an allusion to this. So what I do is, I start with a budget and say there are three parts to the budget. There is product roadmap, there is tech modernization, and there is sustaining engineering. So let me explain what these three things mean. So product roadmap is all the great things that we want to build for our customers. Product managers come in, and your CRO or your CMO might come in and say, hey, here's what we are seeing in the market. We got to go build this. Absolutely, we must go build that. So in general, I like to say that somewhere between 50 and 70% of the spend is in that bucket, depending on the maturity of the organization, the demands in the marketplace, and so on. The second bucket is about tech modernization. So tech modernization is, for example, that going from L0 to L5, that might be something you're choosing to do. You might be moving from running VMs to running containers, or moving to serverless Lambda kinds of solution, right? Those are tech modernization things. And there are lots of, you might be moving from whatever, using a different unmanaged database to using a managed database. All those are tech modernization things. And the reality for me is, it's really like painting the Golden Gate Bridge. You finish the first pass, and wham, here comes this Gen AI stuff. It's like, oh, we need to start over and think about, how do we actually do this again, right? So what I do is put aside somewhere between 20 and 30% of the budget, and say, to actually tell, my partners in the, at the C level, that actually you don't have access to this budget. This is actually tech modernization. We are going to manage it in the tech team. We will tell you what results it will give. It'll give better features, better functionality, better speed, and all that stuff. But this is actually budget that we are going to put aside and not make available for product management, for example. Right. The third bucket is really sustaining, and sustaining is really what is, I think, was referred to as run the business. I mean, that's a reality, right? But run the business is also a bucket you need to pressure a lot. You need to compress that bucket to the optimum level. And I can't, so my experience is, I have come in to a new organization and then found that 60% of their spend is really on sustaining or run the business. How the hell do you ever make progress when that is what your spend is like? You cannot. So unless you put these frameworks in place and say, here are the metrics, here's what we are going to solve for, and our goal is to get to 10 to 15% sustaining engineering, and then measure every single thing and understand what you're doing in sustaining, it's really hard to get to a good outcome. So that's why these frameworks are important. So what I do is every quarter, we sit down and we look at what our output metrics need to be in terms of tech modernization, sustaining engineering, and the product roadmap. And based on that, we set output metrics for ourselves, right? And some of this graph I've deliberately made unclear because this is live data from our current system. Well, what this is actually showing is where my current company is spending money. I've taken out all the legends so that because it is company sensitive information. But every month, every sprint, we actually measure where did we spend our money. And if you're interested in finding out how we do this, please come talk with me. There are actually some off-the-shelf tools we have started using, which are actually pretty phenomenal, right? But I can tell you in a given sprint, what are the outcomes, financial outcomes it's solving for? Are they working on product roadmap kinds of things? Are they working on sustaining engineering? Are they working on tech modernization? How much dollars are being spent in each one of these buckets? Who are the engineers who are working on these things, right? So having that level of inspection in the system actually really helps making sure that you're actually solving for the right things in the system. And every quarter, we are making sure that we are making progress towards this particular, breakdown that you have, and continue to compress down sustaining engineering so that you can put more and more of your bandwidth into the product roadmap. All right. So there are some details around that. I'm not going to go too far into it, but basically, you've got your stories and initiatives. We kind of specify what is the type, what are we, is it for a product roadmap? Is it sustaining work? Did a production incident happen? Oops, sorry about that. What happened here? Did a production incident happen and, we had to spend, we had some unplanned spend in the sustaining bucket, whatever the case might be. We look at what is the core technology which is required for this? Are there other investments we may need to make as a result? What is the revenue impact, the COGS impact, the OPEX impact? So we go through a complete analysis of that, right? So doing this again, I think, makes me more effective and actually makes the engineering team much more effective in delivering value to our customers. All right. So the next thing is managing your cloud expenses. So like I mentioned, COGS, it includes your hosting costs. And for most of us, hosting costs are a consideration. Now, the mental mindset that I have, the framework I use is I'm always looking at the value to cost ratio, right? So whenever, we're having the, I've got an incredibly good leader for our cloud operations who's very, very, he watches our cloud spend like a hawk. And I actually tell him, back off a little bit. And the reason I tell him that is sometimes you got to look at the ratios. You got to look at the value to cost ratios. There are a bunch of people going off and doing experiments, for example, right? I want to encourage that. That's going to cost us money, and that's okay. Because the value that gets realized from running those experiments is sometimes a lot. So, it's really important for us to watch our hosting costs, but we also need to keep in context the value that spend is actually delivering for us, right? So when we're looking at our operating expenses, what is your payroll spend on SREs? What part of that spend can you reduce or when you free up? How does autonomous system increase your velocity? There is a cost to every single time, SREs go into the system and are actually doing something. So at Inflection, our SRE team was 4 engineers. And actually, they spent 0 time on anything to do with serverless. That was our experience. And I think I heard some of that echoed in some of the previous panelists also. But that was actually incredibly liberating, because now they could go off and work on other parts of our code base and our infrastructure that needed a lot of attention, and not have to worry about scaling up and scaling down, and thinking about how much memory is allocated to Lambdas and so on. We didn't actually even think about that. So when you think about your cost of goods sold, I'm going to go into, just because I love this topic a little bit, I'm going to take a slight divergence from this. When you think about cost of goods sold, it's, I generally think in terms of Lambdas. I'm just a fan of Lambdas. I think they solve a huge problem. But you got to kind of decide what you are really trying to solve for, where you are in your maturity curve in terms of traffic, in making decisions about, should I be using Lambda? Should I be using containers? Should I be using something else? And to me, there are a few indicators of that. The key thing to keep in mind is Lambda is all about usage-based, right? The number of requests that you have are a primary determinant of what your bills are going to be. And for containers, it's time-based, right? So you are essentially renting, and you are paying for the time that you have on the container. It's not usage-based. You send 1,000 requests or 100,000 requests, containers don't really care, because you have rented the container. So there is, the pink line kind of shows that, as the number of requests keep increasing Lambda, there is a point in the curve when you actually tip over. Now it's not just the number of requests. There are, it's the duration also, which implies memory. But let's not go into all those details. But there's a point in the curve where it's economically better for you to use containers over Lambda. And I'll tell you, I'm nowhere near that scale. In fact, the first month I actually started at my new company, and we started using Lambdas. For the first 3 months, actually, the first month, my Lambda bill was $7.21, right? Because we fit under 1 million invocations a month or something like that. So we paid a few dollars here and there for, I don't know, network costs or something like that. So if you're running at small scale, it's like, I don't even comprehend why you would not use Lambdas, right? I completely agree that once you reach a certain scale, you need to think about switching to time-based, because it just makes sense at that point. But the startups I have worked with, typically, we don't, at least my past 2 startups, we have not really gotten to a point where that scale was actually meaningful for us. So we just stuck with Lambdas. So the key thing is, you got to find your right price point, usage-based versus time-based. What happens in engineering is people are opinion-based. That is, I like containers, I'm going to use Kubernetes, Fargate is awesome. Or, in my case, Lambdas are awesome. But that's actually the wrong argument to be having. The right argument is, what makes more sense from time to value for customers and the cost to the company. And at smaller scales like I am, I would humbly suggest that Lambdas are an absolute no-brainer. So how do I put all that together? What am I doing on time? Okay. So here's kind of a framework for how you can think about, if you're thinking about autonomous. You take your cloud, what your cloud cost is, and think about how you can reduce it from X to Y. And autonomous systems can actually help you with that by right-sizing, your sizes in cloud. You can remove toil from what SREs are doing. Here the computation is 50% of SRE toil. I'll honestly tell you it was 90% plus when I was at my previous company. Reduce the FCI rate. Now, here's the correlation between removing toil and the FCI rate, and they actually work hand in glove with each other, because when you are right-sizing and knowing what kind of traffic you're serving, and whether you have to scale up at a certain point, or you're throwing away money and therefore you scale down at a certain point, and scaling down typically is, how much memory you have got allocated, you can actually reduce your FCI while maintaining your optimum cost. And the last thing is around reducing latencies. You reduce your latency. Like I said, the correlation back to business results and customers actually completing their workflows is pretty incredible. So you can see that as you go from left to right, you're getting all these savings, and these actually total up. And I would say that in my case, obviously, at my previous startup, when we got acquired, one of the things, I kind of heard through back channel was the company which acquired us basically said, well, we are having trouble competing with you because we couldn't move as fast as you. Now, that's not 100% this. We had an incredible marketing team, which was absolutely killing it on the SEO side. And there were lots of functions which are doing lots of things. But our engineering team was a huge contributor to actually our ability to move fast. The whole pipeline allowing, 15 minutes, code in production with proper blast radius and, with feature flags and all that good stuff, obviously. The ability to ensure that our customer experience is always uniform because we're using autonomous systems was actually a huge help in actually doing this. So I'm a fan. I think autonomous is not the future. It's actually something, teams should be thinking about using today for cost, for value to customer, for speed. To me, it's a no-brainer. Thank you.
All right. Thanks, Siddharth. Time for one question, if we can ask.
Yes.
So I think you've outlined a model for, I would say, kind of the outcomes, planning and measuring how engineering delivers value. Do you have advice for people on kind of how to get started if they like that strategy? Are there particular tools that are sort of used in this? Like, is it all done in Jira, or special tools like Jelly and so on can be used to set this up?
Yeah. So I don't mean to shill any tools, but if someone asks me a direct question, I'll give you an answer. So yeah, we use Jira. And what happens is in Jira, we have a custom field. Every team, when you're doing a backlog grooming and you decide here are the stories that we are going to do in any given sprint, actually marks the story as belonging to one of these 3 buckets. We actually have 4 buckets, not 3, but that's just a detail. So belonging to one of these 3 buckets. And what happens is we have a tool called Jellyfish, which actually reads all the data from Jira and actually automatically creates the graph that I showed you over there with the breakdown into this is how much you're spending on tech modernization and sustaining and product roadmap and so on. And then we compare it against what our goals were at the end of the quarter and figure out where the deltas were. So yeah, that's how we run that part of it.
All right. Okay, thanks very much. Thank you, Siddharth.
Thank you.